Alright, so today we're going to talk at the beginnings about angles and their measures. So first, a whole bunch of definitions. So a ray is a part of a line that has one endpoint and extends indefinitely in the other direction. So it's pretty much like it's a combination of a line and a line segment. It has the endpoint that a line segment has, but it keeps on going forever in one direction like a line will do. Opposite rays these are two rays that share a common endpoint but are considered collinear. So for example, if I have this one ray right here, and I have another ray going in the opposite direction using that same endpoint, and all the points on here are collinear with each other, then those rays are considered opposite rays. Now, if I have two rays that are not collinear sharing an endpoint, they form an angle. So I have one ray there and another ray right there, where the rays themselves are called the sides of the angle, and the endpoint is considered the vertex of that angle. So, for example, if we have this angle right here, BAC, BACA would be considered the sides of the angle, and point A would be considered the vertex of the angle. And we name it by using the vertex as our middle of our three letters, and we use our two other points to create the sides as our estimates. So we would accept it as angle BAC or angle CAB. Either order is perfectly acceptable. Now, different types of angles. An acute angle is an angle whose measures between 0 and 90 degrees. A right angle is an angle whose measures exactly 90 degrees. And our obtuse angle is an angle whose measures between 90 and 180 degrees. And then technically our straight angle is essentially a line. It's an angle whose measures exactly 180 degrees. So those are our four different types of angles. You'll deal a lot with your acute and obtuse angles and right angles as well. Straight angles, not as much by themselves. In other contexts, sure, but not necessarily by themselves. In addition, we have two other concepts, congruent angles and angle bisectors. Congruent angles are two or more angles that have the exact same measurement, very similar to congruent segments concept. Angles cannot be equal since they are not exactly the same, but since their measurements are equal, that's what we call congruent. An angle bisector is a line, ray, or plane that will cut an angle into two congruent angles. So we'll bisect it, cut it into two equal pieces, hence the word bi in bisector. So let's practice naming angles. So if I want to name the vertex of angle 1 in this diagram, well, we go over to angle 1, and it's this angle right here, so the vertex is A. For angle 12, our vertex is point E. And for angle 8, this guy right here, it's a whole bunch of angles, but the vertex of angle 8 is formed right here at this point, which is point F. So identifying vertices of an angle, not very difficult. It's always going to be the point that forms where the angle is starting to create. Now our sides, slightly more complex, but same general concept. So the sides that form angle 7 is side CF right here, and side CD. You also could consider it side CE, since CDE is all collinear, but CD definitely is the side that forms angle 7. Now, if they tell you the angle in this form, DFE, well, angle DFE is angle DFE. It's this angle right here. It's angle 11. How do we know that? Again, F is always the vertex point, and we start by doing the one end to the vertex to the side. There's our angle. Well, if F is the vertex, our side is DF, the first two letters, and FE, the last two letters. So you'll find if you are given the actual name using all 3 points, your sides are the two ends, DF, FE. If you're talking about angle like CBF, it'd be CB and BF. Now angle 2 is this angle right here. So its sides are formed by BA and BF. If we want to say BI instead, that would also be acceptable, seeing that it is still, BF and I are still collinear, so that's okay. It would not have been acceptable to say BG, though, instead of BF, because that would be referring to this angle formed right over here, this black dot. Since that's not what we're referring to, BG would be wrong, even though BG is collinear with BF. It all comes down to it's not the exact same line. BF and BI are essentially the same line, just one is longer than the other. And now naming them, well, again, that's where we use our vertices as our middle points. So with angle 4, the vertex is B, so B has to be the middle. And then two other points that form it, so we have a C, so it's C, B, F. For angle 12, it's this point right here, so E is the vertex, so E is the middle. So it's formed by D, E, then F. So D, E, F is perfectly acceptable. For this one, I also could have said instead FED. That would still be the exact same angle. Just like this one up top here, FBC is also still acceptable. Angle CDF, well, CDF is this one right here. Angle 9 would work for it. That is what the angle is. Also, I could switch around the order. F, D, C. Vertex still has to be in the middle regardless, but I can switch which endpoints I want to use for our sides. So those are our naming angles. Very important since you'll be asked to, you're going to need to identify, the problems will always tell you like angle CDF or angle DEF. They're not going to give all these numbers in here to help you label them. You can fill them in on your own, but you need to identify which angles they're referring to in the future. Okay, so next time we're going to talk about how to actually work with which angles add together, angles equal each other, and stuff like that. So take care.